Hello everyone, welcome back. Today we move to one step further. We are going to implement closed loop voltage control using a PID controller in MATLAB Simulink. So in previous video we successfully designed and simulated a Sepic converter in open loop. So this allows a converter automatically regulate the output voltage even if the voltage or load changes. So let's do a closed loop operations. Why we move to closed loop? Because the open loop system cannot maintain a constant output voltage when the input voltage is fluctuate and also the load resistance varies, and then component tolerance changes. So the closed loop control solves this by continuously comparing the actual output voltage with reference to voltage and adjusting the duty cycle using a PID control to the PWM generator. Let's first we discuss what will happen when the input voltage fluctuate and also the voltage load resistance will be varied. So I'm going to introduce here some value. I put here 0.5 time period. I'm going to reduce the input voltage into 48 to 40. The rest will be input voltage much will be lower here. Then I'm going to add load resistance using a switching state. And just I'm adding a parallel another one resistance through a switch. I specified a time period of 1 second. So therefore I introduce a voltage fluctuate and also load resistance vary. We simulate this one in a open loop operation. You can see here at 0.5 the voltage will be changed. So let's observe here. You can see here it is clearly shown that. So this is the actual voltage we will get nearly 32. So when the input voltage reduces, obviously the output voltage also reduces. So at 0.5 second we can see here the output voltage reduced to 27. And also I furtherly increased the load resistance parallel to the load R. We will get another more reduced voltage in output side. Nearly it reaches to 25 voltage. You can clearly observe here. When the load will be varied, the current also will be what? Increased here. You can see here in earlier we are getting nearly it is equal to 7.5 amps. Then when the load is increased, we are getting nearly it is equal to 22.5 something, nearly it's equal to 23 amps. So let's add a PID controller. Okay, let me see closed loop control. We set a reference voltage. The reference voltage I choose a constant block D constant block. So the reference voltage is our output voltage. I set here V out. So that is going to be 32 voltage. I applied here. Then we need to the output voltage V naught is measured here. The compared with comparator. And then generate the error. So this is the actual signal. Actual signal is compared with this is the reference signal. And then the error is given to the PID controller. I already tuned the PID controller based on the transfer function approach. So this PID controller processes this error and generate the corrected duty output cycle to this PWM generator. Now connect the PID controller to the PWM generator. I hope you understand how it is operated. Let me simulate this one. So you can see here at 0.5 second we introduce the error, that is when we reduce the input voltage 5 voltage, we are getting 43 volt, and also at the exactly time period of 1 second we added another one resistor load, that is going to be 1.5 ohm. So you can see the actual resistance value R is equal to 4.09. More resistance R in parallel with the actual load resistance. Let me simulate. So you can see here at 0.5 second. So it is more or less nearly maintain the same voltage. See here the output voltage. So this is the input voltage. At 0.5 second the input voltage 48 voltage will be reduced to 43 volt. At this period you can see here we will get some oscillations because I didn't tune my PID controller properly for simulation for understanding the concept. You can see here. Then at exactly time period 1 seconds we adding another more resistive load. See here the voltage is nearly maintained 32. This is the closed loop control of Sepic converter with the help of PID controller. In the simulation, we will observe the converter should smoothly reach the reference voltage. Then suddenly load changes at the period of 1 period of second. So the PID must bring the voltage back to the reference. The complete the closed loop Sepic converter simulation with the PID converter. This is the next step after the open loop design and makes the converter more practical for real-time systems like a PV MPPT, battery charging, and a LED drive and automotive power application. If you want the Simulink, you can contact me on WhatsApp, link in description. Don't forget to like, share and subscribe. Thank you all.